Next problem. Compare the strength of two beams of rectangular in section and size of 660 mm into 100 mm and 60 mm into 120 mm. So compare the two rectangular cross section of the beam. First write down the given data. Width of the first beam equal to B160 and depth equal to 100. So second case B260 and second depth is D2 equal to 120 mm. So what we find, the ratio of strengths of the two beams. Ratio of strengths of the two beams. So here the solution, section modulus, we just consider the section modulus of first beam. Section modulus formula equal to Z1 equal to B1 into D1 square divided by 6. That BD square divided by 6. So 60 into 100 square divided by 6. Answer is 1 into 10 power 5 mm cubed. Section modulus of second section Z2 equal to BD square divided by 6. So corresponding B2 D2, the answer is 1.44 into 10 power 5 mm cubed. The strength of the beam is proportional to its section modulus. Consider the strength of the beam is proportional to its section modulus. So the strength of the first beam divided by strength of the second beam equal to Z1 by Z2, and the ratio is 1.10 power 5 divided by 1.44. Answer is 0.6944. Result is the ratio of strength of the two beams are 0.6944. Next problem. A beam of I section 300 mm into 150 mm has flange 20 mm thick and web base 13 mm thick. Compare its flexural strength with that of the rectangular section of the same weight and same material when the depth being twice the width. So case is comparison. So you consider the first of all cross section of the beam like this, 20 mm web thickness, here is the 13 mm and 150 deep and 300 mm wide. So this is the cross section. Just we comparison, the comparison of flexural strength. First of all, area of I section of this section equal to 300 into 20, 300 into 20 plus 13 into 110, 13 into 110 plus 300 into 20. So this is the area, and then moment of inertia of I section equal to BD cubed by 12. So overall moment of inertia minus inner one, that is the case 52.542 into 10 power 6 mm power 4. The section symmetrical about xx. The section is symmetrical about xx and yy axis. So therefore y max equal to y bar equal to 150 divided by 2. Overall height divided by 2. That is 75 mm. Section modulus of I section Z1 equal to I equal to y max, that is equal to 52 into 10 power 6 divided by 75. The answer is 7.005 into 10 power 5 mm cubed. Let B equal to width of the required rectangular section. B equal to width of the rectangular section. D equal to depth of the rectangular section. Then D equal to 2 times of the B. This is given data. For same weight of two beams made of the same material, the area of the two beams must be equal. Therefore, area of the I section equal to area of the rectangular section. Area of the I section equal to area of the rectangular section. So just we compare 430 equal to B into D. So given data B into 2B, so here 2B square equal. From this we got B square equal to 67115. So B equal to root of this one equal to B equal to 81.945. So depth of the beam is 2 times the B, that is equal to 163.89 mm. So section modulus of the rectangular section is Z2 equal to BD square divided by 6. So here the 81.945. So put the breadth and the depth. Answer is 3.668 into 10 power 5 mm cubed. The strength of the beam is proportional to its section modulus. As we know, the strength of the beam is proportional to the section modulus. Therefore, flexural strength of I beam divided by flexural strength of the rectangular section equal to Z1 into E1 divided by Z2 into E2, which is nothing but Z1 by Z2. For same material, Young's modulus equal to same material, Young's modulus equal to same. So 7.005 into 10 power 5 divided by 3.668 into 10 power 5. Answer is 1.9009. Finally, the ratio of the flexural strength of two beams are equal to 1.9009.